Welcome, scholars. Today we're going to take a look at Chapter 2, Big Concept Number 3, the remainder and factor theorems. And when I say we have a lot of information to go through today, we have a lot. So let's take a look at our learning targets. I am learning to divide polynomials using long division and synthetic division, and I'm learning to use the remainder and factor theorems. So first thing, we're just going to start off with an example. Long division. You probably did that in early elementary school or mid-elementary school. Who knows? It's been a long time since I've actually learned long division because I'm older than you all by a lot. So let's consider the polynomial function f of x equals 6x cubed minus 25x squared plus 18x plus 9. If you know that f has a 0 at x equals 3, then you also know that x minus 3 is a factor, which means you can use that long division to determine if any other zeros exist. All right, so we have a numerator of 6x minus 3 minus 25x squared plus 18x plus 9, and a denominator of x minus 3. So let's go ahead and set that up with our long division. So we actually take our denominator, x minus 3, we put it over here, and then over inside we have 6x cubed minus 25x squared plus 18x plus 9. And now we have that division bar. So first things first, I have an x. What do I have to multiply x by to get 6x cubed? Well, if you said 6x squared, you'd be correct because this has a numerator of 1, or a coefficient of 1, so 1 times 6 gets us 6, so it goes 6. X to get x cubed is x squared. Notice I'm putting that 6x squared above my x squared term here. So now I'm going to multiply x and 6x squared, which is 6x cubed. And then I'm going to multiply negative 3 times the 6x squared, which gets us negative 18x squared. All right, my goal is to cancel these out. Right now, they are the same, so I need to make them opposite. To do that, I have to subtract. So if I subtract here, I change this sign here to an addition. These will cross out, and this now becomes negative 7x squared. And now I just drop down that plus 18x. All right, so now I'm going to take a look at my factor over here. What do I need to multiply x by to get negative 7x squared? Well, if you said negative 7x, you'd be correct. So negative 7x times x is negative 7x squared. Negative 7x times negative 3 is positive 21x. However, right now, my signs are the same right here. They have to be opposites. So if I make this one a plus, this one becomes a minus. So all we're doing is changing our signs. These cross out. 18x minus 21x is 3x. And I have 3x. And the plus 9 drops down. All right, so now, what do I have to multiply this x by to get 3x? Well, if you said plus 3, you'd be absolutely correct. Oh, except Miss Younger messed up. 18x minus 21x is negative 3x. So what do I need to multiply x by to get negative 3x? The answer is negative 3. Whew, good thing we caught that mistake. So negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. We have to make these opposite. So this becomes plus. This one becomes minus. They both cancel, and I'm left with a 0. Which means my remainder is 0. So this answer When I divide 6x cubed minus 25x squared plus 18x plus 9 by x minus 3 is x minus 3 times 6x squared minus 7x minus 3. All right, so now we can factor to get all of my zeros. So I'm going to say factor to get all possible real zeros. All right, so factoring. And as pre-cal babies, you should know how to factor. So I'm just going to go from here, x minus 3. This negative 7x. Becomes a negative 9x plus 2x. I'm basically building that bridge as Mrs. H calls it. I'm going to find my common factor. So this is 3x, and I'm left with x minus 3. Oh, this is not x minus 3. This is 2x minus 3. And then plus 1. I'm left with 2x minus 3. So my factors are x minus 3, 3x plus 1, and 2x minus 3. Disclaimer: if you need help factoring, set up a meeting with me. We'll make you factoring pros. All right, so now we have all of our factors. We now are going to set each of these factors equal to 0. So x minus 3 equals 0, which means x equals 3. 3x plus 1 equals 0, which means x equals negative 1/3. And 2x minus 3 equals 0, which is 2x equals, x equals 3/2. All of those are my zeros. Pretty nifty, huh? So just put them down again. 3, negative 1/3, and 3/2. All right, so long division of polynomials can result in a zero remainder, as we just saw, or a non-zero remainder. So let's take a look. Let's do another example. Here we have a denominator of x plus 2, so I'm going to pull that over here. And then we have x squared plus 5x minus 4. All right, to get x squared, what do we have to multiply x by? Well, just x. So I'm going to put it over the x column. And so x times x squared, or x times x is x squared. X times 2 is 2x. All right, subtract. Subtract. These cancel. I now have 3x minus 4. What times x gives me 3x? We say 3. So when we multiply 3 times x, we get 3x. When we multiply 3 times 2, we get plus 6. So now change our signs. These x's disappear. This becomes negative 10. That is my remainder. This time I have a non-zero remainder, which means my answer when I divide ends up being x plus 3 minus 10 over that denominator of x plus 2, right? And now we have a domain restriction that says x cannot equal negative 2. And just a reminder, this right here is that remainder. All right, let's keep going. Let's do another example. We're going to divide 9x cubed minus x minus 3 by the quantity 3x plus 2. So here we have the 3x plus 2. We have our 9x cubed. Now notice I went from a cube to an x. What are we missing? If you said x squared, you're absolutely correct. So we need to make sure we are accounting for that x squared. So we're going to make sure we have 0x squareds, and then we continue on with that polynomial of minus x minus 3. All right, so what do we have to multiply 3x by to get 9x cubed? Well, 9 divided by 3 is 3, so I'm going to do 3. X cubed divided by x is x squared, so 3x squared. So now, 3x squared times 3x is 9x cubed. 3x squared times 2 is 6x squared. Now we're going to subtract, so change our signs. These cancel, and now I'm left with negative 6x squared. Minus an x. All right, now let's do this again. Negative 6 divided by 3 is negative 2. X squared divided by x is x. So now let's multiply. Negative 2x times 3x is negative 6x squared. Negative 2x times 2 is negative 4x. However, since I'm subtracting, I'm changing all my signs. These cancel. I now have 3x. Bring down the minus 3. All right, so now 3x goes into 3x 1 times, and this is plus 1. And I'm left with 1 times 3x is 3x. 1 times 2 is plus 2. Change my signs. These cancel, and I have a negative 5 right here, which is my remainder. So here my answer becomes 3x squared minus 2x plus 1. 3x squared minus 2x plus 1. And then we have a remainder of minus 5. And then we put, remember, we're putting it over the denominator of 3x plus 2. And here we have x cannot equal negative 2/3 because that is that domain restriction. All right, let's do another example. Trust me, the more examples, the better. This time, we have a polynomial and a trinomial. So we have x squared minus 2x plus 7. And then we have 2x to the 4th minus 4x cubed plus 13x squared plus 3x minus 11. All right, so taking a look at this first term, what do I need to multiply x squared by to get 2x to the 4th? Well, it is 2x squared. So I'm going to come to the x squareds, and I'm going to put 2x squared. So 2x squared times x squared is 2x to the 4th. So we have our 2x to the 4th. 2x squared times negative 2x becomes negative 4x cubed. So far, so good. 2x squared times 7 becomes positive 14x squared. So now we're going to change our signs because we're subtracting. These cancel out. These cancel out. And this just becomes negative x squared. And then we're going to drop down our plus 3x minus 11. All right. What times x squared gets me negative x squared? And if you said negative 1, that would be absolutely correct. So I'm going to multiply every single term here by negative 1, which gets me that negative x squared plus 2x minus 7. Because I'm subtracting, I change all of my signs. These cancel. This becomes an x, and this becomes minus 4. So now our remainder is x minus 4. So our answer is 2x squared minus 1 with x plus x minus 4 over x squared minus 2x plus 7. And then we'd have to find those domain restrictions where x cannot equal. All right, going on to our next example. We're going to talk about synthetic division. Wow, synthetic division, that's a biggie. But it goes by really, really nice. It's much nicer than that long division, so trust me when I say learn synthetic division. So synthetic division is the shortcut. Miss Younger, why on earth didn't you give us the shortcut to begin with? Well, it's because you need that productive struggle to appreciate synthetic division. So steps for completing synthetic division: write the coefficients of the dividend in standard form. Write the related 0c of the divisor in the box. Always bring down the first coefficient. Multiply the first coefficient by c. Write the product under the second coefficient. Add the product of and the second coefficient. Repeat until you get the final number. All right, Miss Younger, what in the world did you just say? So first, let's take this and set it equal to 0. X plus 2 equals 0. So x equals negative 2. This is my 0. Or in this case, that c that we were just talking about. So I'm going to take that negative 2 that we just talked about, and I'm going to put a box around it. Now, we have an x to the fourth. What is the coefficient? It's 2, so I'm going to put a 2. After x to the fourth comes x cubed, but I don't have any. So I'm going to put a 0. This is going to represent my x cubes. My x squareds, I have negative 5. My x's, I have positive 5. And my constant, I have negative 2. All right. So all of these were my coefficients. First things first, I'm going to drop the 2. All I did was drop it. Now I'm going to multiply negative 2 times positive 2, and that gets me 4. Negative 4. And so now I add 0 plus negative 4, which is negative 4. Multiply negative 2 times negative 4. That gets me that positive 8. Add straight up and down. Negative 5 plus 8 gives me 3. Multiply negative 2 and 3 gets me negative 6. 5 plus negative 6 gets me negative 1. Negative 2 times negative 1 gets me that positive 2, gets me my 0. That right there is my remainder. So when I divide everything by that x plus 2, my answer is 2x cubed, because the 2 minus 4x squared plus 3x minus 1. We start, our first exponent is 1 less than the exponent we started with. And then these become my coefficients of the remaining terms. That's it. That problem is done. So let's do this again. All right, so we have 10x cubed minus 13x squared plus 5x minus 14 divided by 2x minus 3. So here we go. We have to take this 2x minus 3, set it equal to 0. We get x equals 3 halves. So I'm going to go over here. I have my 3 halves and put it in a box. All right. Actually, that's the hard way. I don't want to do it the hard way. Let's do this a different way. All right, I'm going to rewrite this. 10x cubed minus 13x squared plus 5x minus 14, all over 2x minus 3. So first things first, I want to get this x to be a single x, so I'm going to multiply everything by 1/2 because that is the reciprocal of 2. What happens there is I get on top 5x cubed minus 13 halves x squared plus 5 halves x minus 7 all over x minus 3 halves. So now, when I set this to 0, I have x equals 3 halves. So I'm still going to come over here and I'm going to have 3 halves, but my new coefficients are 5, which is a smaller number, negative 13 halves, 5 halves, and negative 7. All right, so just like last time, I'm dropping the first one. 5 times 3 halves is 15 halves. All right, so now I'm adding negative 13 halves plus 15 halves is a beautiful 1. All right, 3 halves times 1 is 3 halves. 5 halves plus 3 halves is 8 halves, which is 4. Ah, look at these nice, pretty numbers. 3 halves times 4 is 6. Negative 7 plus 6 is 1. That becomes that remainder. And so my answer becomes 5x squared plus x plus 4 plus 1 over x plus 3 halves. Or if you want to go ahead and change that x plus 3 halves back, this becomes 5x squared plus x plus 4 minus 2 over 2x minus 3. And that's because the first thing we did was multiply both of these by 2, both my numerator and my denominator, to get rid of that fraction. Either one of these are acceptable answers. All right, so let's take a look. Now we have what we call the remainder theorem. And in short, we're going to use the fact that if a polynomial is divided by x minus c, then the remainder is r equals f of c. And we do this by using that synthetic division and synthetic substitution. Because we know x minus c is a factor. If x minus c is set to 0, then x equals c. So all we're going to be doing is substituting in. It sounds crazy, it sounds difficult, but trust me, it is not. All we're doing is evaluating a function at x equals c. So now we're going to use both the factor theorem and the remainder theorem, actually just the factor theorem, to determine if the binomials are factors of f of x, and then use the binomials that are factors to rewrite the factored form of f of x. So here we go. We take this, we go x minus 1 equals 0, so x equals 1. And we take this one, x plus 3 equals 0, and x equals negative 3. These are the two c's that we're checking to see if they are factors. So all we do is evaluate. First, f of 1. So f of 1 is 4 times 1 to the 4th plus 21 1 cubed plus 25 1 squared minus 5 times 1 plus 3. All right, so that says 4 plus 21 plus 25 minus 5 plus 3 equals 48. Because 48 does not equal 0, x minus 1 is not a factor. So now we're going to do f of negative 3. So 4 times negative 3 to the 4th plus 21 times negative 3 cubed plus 25 times negative 3 squared minus 5 times negative 3 plus 3. All right, So this becomes 4 times 81 plus 21 times negative 27 plus 25 times 9 plus 15 plus 3. All right, so when we keep simplifying this down, we actually end up getting 0. So because 0 equals 0, x plus 3 is a factor. All right, because x plus 3 is a factor, we're now going to use that synthetic substitution and that synthetic division to find out what that factored form is. So we take our negative 3, which is our c, and we take our coefficients of 4, 21, 25, negative 5, and positive 3. Bring down the 4. Negative 3 times 4 is negative 12. All right, add straight up and down. 21 plus negative 12 is 9. Negative 3 times 9 is negative 27. So 25 plus negative 27 is negative 2. Negative 3 times negative 2 is positive 6. So negative 5 plus 6 is 1. Negative 3 times 1 is negative 3. So we have that 0 of a remainder. So it asked for that factored form. So our factored form becomes x plus 3, which was our first factor, times 4x cubed plus 9x squared minus 2x plus 1, where these were the coefficients pulled from that synthetic division. So that was our factored form. All right, one more example. Let's go. So just like before, we need to find those c values. So x plus 4 equals 0. So x equals negative 4. X minus 5 equals 0. So x equals 5. So those are my two c values that we're going to use for that factor theorem. So first one, f of negative 4 equals 2 times negative 4 cubed minus negative 4 squared minus 41 times negative 4 minus 20. So we get 2 times negative 64 minus 16 plus 205, not 205, Miss Younger, you're being silly, plus 164 minus 20. So negative 128 minus 16 plus 164 minus 20. And when we simplify that all down, it does in fact get us 0. So yes, x plus 4 is a factor. So because it is a factor, let's go ahead and do that synthetic division real quick. So negative 4, then we have our leading coefficients of 2, negative 1, negative 41, and 20. So drop down our 2. Negative 4 times 2 is negative 8. Negative 1 plus negative 8 is negative 9. Negative 4 times negative 9 is positive 36. Negative 41 plus 36 is negative 5. Negative 4 times negative 5 is positive 20. So here we have a 0, which is our remainder. So my factored form now is x plus 4 2x squared minus 9x minus 5. So that is a factored form. All right, now it says check x equals 5. So now we do f of 5. So 2 times 5 cubed minus 5 squared minus 41 times 5 minus 20. All right, so we get 2 times 125 minus 25 minus 205 minus 20, which gets us 250 minus 25 minus 205 minus 20, which does actually simplify down all the way to 0. So yes, once again, this time x minus 5 is a factor. However, because we've already done our factored form once, we're actually going to use our synthetic division using this 2x squared minus 9x minus 5. So we have 5 is our c. Our leading coefficients are 2, negative 9, negative 5. Bring down the 2. 5 times 2 is 10. Negative 9 plus 10 is 1. 5 times 1 is 5. 0. I have a 0 remainder, which is awesome. All my work is working out the way I want it. So this becomes x plus 4, because we knew that was a factor. X minus 5, because yes, we just proved that was a factor. And then we have 2x minus 1. And that is our factored form. From here, you could find your zeros even further, but we're not going to do that for today because this has been a long enough video. If you have any questions, please do not hesitate to ask, especially with this synthetic division, the remainder, and factor theorems, because we will be using this a lot over and over and over again, especially in Chapter 2. So please, if you have any questions, contact me, Mrs. Younger, because I am here to help. Bye, scholars.